Recording in progress.
Hi students, in this lecture I am going to discuss problems based on gravitation. Let us see first one. As Saturn is revolving around the Earth, given orbit shape is circle, radius is r, velocity v naught. A monkey is jumped from the satellite in forward direction with a relative velocity root 5 by 4 minus 1 into v naught. Calculate its minimum and maximum distances from the Earth's center during subsequent motion of the monkey. So given radius is r and v naught corresponds to orbital speed, given velocity of monkey relative to satellite. So we have to calculate now minimum and maximum distances. Let us see how to start the problem. So whenever any question given basing on these satellites, we can use one is conservation of mechanical energy and second one conservation of angular momentum. Okay, let us see that given data orbit shape is circle, radius is r, velocity always along a tangent. Now given that a monkey jumps in forward direction with a relative velocity v relative is equal to root of 5 by 4 minus 1 into v naught, where v naught is root of g m by r orbital speed, right? Then velocity of monkey becomes v naught plus vr because both are in the same direction, which is equal to root 5 by 4 root 5 by 4 v naught. Okay, and you can see here at the time of jumping, angle between the velocity vector and radius vector it is 90. That means this separation corresponds to minimum separation. So we have learned that at the time of maximum separation or at the time of minimum separation between the radius vector and velocity vector, angle is 90. So now at the time of jumping between these two angles 90, that's why this is a corresponding to minimum distance. Why it is a minimum means because here velocity has increased. So this is now corresponding to maximum velocity. Okay. So now we have to calculate what is maximum separation. So first equation is, so we are conserving mechanical energy. So law of conservation of mechanical energy. See the first equation, separation equal to what? So potential energy minus Gm m. Capital M stands for mass of the earth, small m is for monkey, by separation is R, plus kinetic energy half m 5 by 4 v naught square. Okay, and v naught value is known that we can substitute here. That is equal to minus g m m by, take it as r dash, which is maximum separation, plus at that time velocity equal to, take it as v dash. So v dash square. You can see here r dash and v dash. We have two unknowns. So we require one more equation, that is conserving angular momentum. Relation is that force is always passing through center of the earth. Therefore, about center of earth, the net torque equal to 0. Right? So writing here m into V value root of 5 by 4 V naught MVR. Angle is 90, so sun 90. That is equal to M velocity V dash distance R dash into sun 90, because R dash corresponds to maximum. Now we want to calculate R dash. Therefore, in the place of V dash, we can write now this value by R dash in this place, right? And after simplifying, we are going to get R dash equal to, it is 1 is R, means we are going to get here quadratic in terms of R dash. So one root will be R and second will be 5R by 3. That means this is now corresponding to minimum separation and this is corresponding to maximum separation. Okay, right. Let us see next problem. An Earth satellite is revolving in circular orbit of radius r with a velocity v naught. A man in the satellite jumped directly towards the Earth with a velocity v naught by 2 relative to satellite to reach the Earth. Later he realized that he made a mistake. Calculate maximum and minimum distances of the man from the center of the Earth during his subsequent motion. Assume that the man's mass is very small compared to that of the satellite. So almost same as the previous problem, only change is now he jumps towards Earth. Okay, remaining as it is. Radius is given Kepler, velocity v naught. Just see equations. Again, same equations. See where change comes. Again, shape of orbit given circle. But now this time the person jumping towards the Earth, velocity v naught by 2 and velocity of a satellite v naught along tangent. And say given one sentence here, he made a mistake. So why he made a mistake means when he jumps towards the Earth, his velocity becomes now like this because he is also having velocity because of motion of satellite. That means his velocity will be now resultant of v naught and v naught by 2. It will be like this. That means he cannot reach the Earth. That's why he made a mistake. Okay. And we are given one more thing. Assume that mass of the man is small compared to that of satellite. The reason is that when he jumps towards the Earth, satellite has to recoil backward like this. But since it is given man mass is very small, it indicates that we have to neglect recoil velocity of the satellite. Okay. Now see equations. Coming to equations, radius is given r capital R. First, conserve mechanical energy, that is minus G by R potential energy plus kinetic energy half M V naught square plus V naught square by 4 equal to minus M by, take a small r, that may corresponds to maximum separation or minimum separation plus corresponding velocity, take it as v, half m v square. Okay, that is our energy equation. Now we have to focus conservation of angular momentum m v value. Because of this component, there is no angular momentum, it is only because of V naught. Okay. So M V naught R, that is equal to, when separation is minimum or maximum, it is MVR into sine 90. Okay. So M gets cancelled. In the place of V, now we can write, in the place of V, we can write V naught R by R. Substitute this in the first equation and we are going to get here quadratic in terms of R. Okay. It comes out to be quadratic and that equation will be, so after simplifying that, we are going to get, it is 3R square minus 8RR plus 4R square equal to 0. So solving for R, we are going to get roots. One is 2R and second one is 2R by 3. So 2R by 3 corresponds to minimum separation and 2R corresponds to maximum separation. Okay. So previous question and this question almost same. So we have taken same equations, right? Okay. See now, next problem. Inside a fixed sphere of radius r and uniform density rho, there is a spherical cavity of radius r by 2 such that surface of the cavity passes through center of the sphere as shown. A particle of mass m is released from rest at center B of the cavity. Calculate the velocity with which particle strikes the center A of the sphere. Neglect Earth's gravity. Initially, sphere and particle are at rest. Right? Given now, this is a cavity. Releasing from B, we have to find velocity when it touches C. Right? See how we are going to solve the problem. Given R by 2 density rho. Density rho, mass is M. Right? And given start from rest. Neglect Earth's gravity. First, let us make a diagram for that. So first, we are going to focus what is acceleration inside cavity. Inside cavity. Or let us take some generalize this one. Instead of taking this diagram, let us generalize now. Right. Suppose there is a cavity inside. It is now like this. This is now center of cavity. Let us calculate now at any point inside cavity what is gravitational field. Suppose taking a point here. It's a position vector with respect to center of bigger one. Take it as R1 bar. With respect to center of a cavity, take it as R2 bar. Okay. Let us take now separation between the center of a cavity and center of bigger one is A. Okay. Then see how to find now field inside. Field inside. So take it as A bar. Okay. So first of all, just recollect once inside a solid sphere, G value Gm by R cube into R. Right here in the place of m, in terms of density, 4 by 3 pi r cube volume into density, that is a mass, into r. See what we are going to do, r cube gets cancelled. 4 by 3 pi g rho r. Okay. This is now strength of the field inside solid sphere where r is distance from center. Okay. Now what I'm doing is that this cavity can be taken as, so we are taking now, there is a one bigger sphere having mass positive. This is only for calculation purpose. Mass is positive. And smaller one having mass negative. Assume both have same density. One is a plus rho and one is minus rho. So one is having positive mass and one is having negative mass. When we superimpose these two, the overlapped region becomes a cavity. I am repeating. When we superimpose these two, the overlapped region becomes a cavity. Now, because of this positive mass, imagine here one positive mass. This positive is attracting that positive. That means because of the bigger one, G1 or G1 bar is equal to 4 by 3 pi rho G into minus R1 bar. It is attracting. Second one, G2 bar, because of the negative mass, 4 by 3 pi, rho is now minus rho into G minus R2 bar. Okay. Now take resultant of these two. Now take resultant of these two. That gives us 4 by 3 pi rho G. It is R2 bar. It is R2 bar minus R1 bar. Okay. So which is nothing but 4 by 3 pi rho G. In the place of R2 bar minus R1 bar, we can write minus A bar. So this indicates that at any point inside cavity, gravitational field is uniform, means having same modulus value, and direction is from center of the cavity to center of bigger one. Now in this problem we are given center of the cavity and center of the bigger one separation equal to r by 2, right? Then see what we can do. G value how much means 4 by 3 pi rho G. A value is now r by 2. Okay, that is now acceleration. And condition is given that it is released. It is released from rest. Therefore, now what I can do is here initial velocity is 0. Final velocity we have to calculate. Acceleration is now g. Okay, this is g. And displacement is now r by 2. Because center of cavity to center of bigger one, distance given is r by 2. So now here see what we can write. V square minus u square equal to 2as, right? So v equal to root of 2, a value 4 by 3 pi rho g into r by 2. S is r by 2. Okay. Now see what we are going to get. 2 and 2, 4 gets cancelled. Remain 2 by 3. Root of 2 by 3 pi rho g r square. This is now velocity with which it touches now point A, right? See careful ones. We got g value, u 0, v we have to calculate. A equal to G, S equal to R by 2. So equation is V square minus U square equal to 2AS, right? So here this point you have to remember inside cavity field is uniform. Direction is from center of cavity to center of the bigger one, right? Okay, see next one. A projectile of mass m is fired from the surface of the earth at an angle alpha equal to 60 from the vertical. The initial velocity V naught equal to root of G m by R, me mass of earth, Re radius of earth. Okay. How high does the projectile rise? Right. See how we are going to solve this one. Given angle 60 with vertical and velocity root Gm by R. So first write down the given data. With vertical. Suppose projecting from here, then this becomes vertical. Velocity is now like this. This angle is given now 60. Okay. Then and velocity given v equal to root of g m by r. M is mass of earth, r is radius of earth. Then you can see path will be, it will be like this, right? Again, when you can see, if you observe, when separation becomes a maximum, velocity will be normal to radius vector. Okay. So here see what we can write. First we are writing law of conservation of mechanical energy means a continuous potential, that is minus G m by R potential energy on surface of earth, kinetic energy half m v square. It is half m v square. This is initial energy, right? At the time of projection. Okay. Next, when it is at maximum height, kinetic energy half m, or take this as v naught to avoid confusion, v naught half m v square. Potential is now minus g m by, so take it as it is now r maximum. Okay, it is equal to r, which we have to calculate, right? Next, if you observe here, one is v unknown and r also unknown. We have two unknowns. So we require one more equation, that is now law of conservation of angular momentum. Okay. So initially m v naught sine 60 into r, that is equal to, when separation is means when height is maximum, then m v r, because between v bar and r bar angle is 90. Okay. So we want to calculate maximum height. So I want to eliminate now v value. So in the place of v, what we can write? V naught, right? Sine 60 root 3 by 2 r. So in the place of v, we can write this value. Now substituting that in the first equation, right? Then we are going to get, from that we are going to get r value. It will be 3r by 2. But question is now find maximum height. So this is nothing but r plus h. Okay, maximum height. That means h value how much? It is equal to 3r by 2 minus r. It is r by 2. Okay. So like this, we can get maximum height. Okay.